Hello, namaste everyone. Hope all of you are well. Actually, in this thermodynamics chapter, total we have completed our six lectures, and this is our seventh lecture. In this, we are going to discuss about the Hess law of constant. First of all, in the previous lectures, whatever we have studied, just take a review. We have gone through the what is thermodynamics, system and surrounding, types of system, heat, work, first law of thermodynamics, enthalpy, other state functions, pressure, temperature, volumes, internal energy. As further we have moved towards the reaction enthalpy, standard reaction enthalpy. In the previous video we have discussed about the standard reaction enthalpy, and in this video we are going to discuss about the Hess law of constant heat summation. You know very well, in any reaction, sometimes what happens, the reaction complete in one step, and many times the reaction complete in 2 or 3 steps, but we just see only one step. Yeah, it can complete. Just suppose here that here A to B, if reaction is here, these are reactant and this is product. Just it has shown you that within a step the reactant has converted into its product. But if I talk about that they have two several steps, C and D, then they have completed to the B. So there are sometimes we just see a normal reaction that from the reactant it is directly converted into the product. But sometimes it happens that it takes 2 or more than 2 steps also, right? So here the Hess law is nothing else. The Hess law, if a reaction takes place in several steps, then its standard reaction enthalpy, remember this word, standard reaction enthalpy, is the sum of the standard enthalpies of intermediate reactions into which the overall reaction may be divided at the same temperature. Now you should know that what it means to say. What is Hess law? Hess law is nothing else. It is, you have to calculate the standard reaction enthalpy. Either you go in one step or the number of several steps. It is the sum of all the intermediate reactions enthalpies. Overall reactions may be divided into same temperature. Yeah. Question is, the temperature should be same. As already I have told you in the extensive and intensive properties that temperature is it is not an extensive property, it is an intensive property. So definitely temperature will be same for either A, B, C, A, C, D or A to B. Now, as we have understand the concept, now I would like to tell you that have you ever thought that some of the reactions are independent, some of the reactions are not independent, and some of the reactions have many more things that we should know about it? Have you ever thought about it, that how do these things happen really? Actually, why I am telling you these things because I just want to tell you that if you take a reaction, just suppose that sometimes what happens when we clean our verandas or our house, after cleaning whatever the garbage we get, we directly burn that garbage. But some plastics do not burn, they do not get a sufficient amount of oxygen, so that carbon do not burn, it get a lack of oxygen, so it convert into carbon monoxide, right? It convert into carbon monoxide. Now you have understand, if this carbon monoxide, what will be the delta, or you can say heat enthalpy reaction, delta HR. If just suppose here I have given you one reaction, carbon plus half O2 is carbon monoxide. You have to calculate that what is the enthalpy rate of reactions. Means here you have to just calculate in this reaction what is the rate of enthalpy, what is the rate of reaction in this enthalpy. Now, although we know very well carbon monoxide is a major product, but carbon dioxide gas, generally because of the lack of oxygen we get carbon monoxide. But if I talk about, we cannot measure the enthalpy change for this reaction, carbon plus half oxygen is equal to carbon monoxide. We can't find out. We have to give some of the steps, like this. We have burned the graphite, carbon plus oxygen is equal to carbon dioxide. To burn, as we have already, I have told you about the exothermic and endothermic reaction. In the chemical bonding also I have said you, whenever the two elements lower its energy, which energy? That is the enthalpy only here, as we have told you that delta HR for carbon plus oxygen, carbon dioxide, when carbon burn with this graphite burn and it produces a carbon dioxide, that time it releases with this rate of reaction enthalpy is minus 393.5 kilojoule per mole. But if I talk about the same thing, if I convert, when the carbon dioxide has been converted to carbon plus oxygen, then it will be plus 393.5 kilojoule per mole. Because as I have told you that the rate of reaction, what rate of reaction? Especially about the exothermic and endothermic reaction. Exothermic reaction and endothermic reaction, as you know very well, that in the exothermic reaction what happens? The heat evolves, and endothermic reaction, heat involves. So that's why here, as I have told you, carbon plus oxygen, carbon dioxide, the enthalpy rate of reaction is minus 393.5 kilojoule per mole. And second step is, if I just suppose carbon monoxide plus half oxygen, then also carbon dioxide, and here the heat of the enthalpy reaction is minus 283 kilojoule per mole. Now question is that sir, how you have found? See, whenever we talk about this enthalpy of reaction, remember that in the previous video I talked about the standard enthalpy reaction and previous to previous reactant enthalpy reactions. Have you remembered that delta HR is equal to summation of product enthalpy reaction minus summation of reactant enthalpy reaction? If you have remembered, then you may be knowing about that. What is this enthalpy rate of reactions, right? So here, as I have told you, that carbon plus oxygen, carbon dioxide produces delta HR is minus 393.5 kilojoule per mole, and carbon monoxide plus oxygen, carbon dioxide, it gives minus 283 kilojoule per mole. Now question is, we can combine these two reactions in such a way that we can directly get a carbon monoxide. Means we have to combine this both the reaction. Just suppose here, as I have told you, that here carbon plus oxygen, carbon dioxide. Now carbon dioxide will convert into carbon monoxide plus half oxygen. This is second reaction. Just see, this is the equation number first, this is equation number second. And in the third reaction, what I have done, carbon dioxide splits carbon monoxide plus half oxygen. That time, the delta HR value will be positive, it will not be negative. Why it will be positive? Because here you can see the product is here carbon monoxide plus half oxygen and reactant is carbon dioxide. So that's why here endothermic reaction 283 kilojoule per mole, it will be in positive. Now what we have done? We have just taken adding the reaction first one and third one. So I will get the first one, whatever the question was there, carbon plus half oxygen is equal to carbon monoxide. I want to calculate the rate of enthalpy in this reaction. In this reaction, I was trying to calculate the enthalpy force. So first of all, what I have done, I have taken the several steps. According to the several steps, I have got the delta heat enthalpy reaction, adding 1 and 3, carbon plus half oxygen, that is carbon monoxide, delta HR is equal to minus 393.5 kilojoule plus 283 kilojoule per mole, that is minus 110.5 kilojoule per mole. So actually why I have elaborated these all the things? Because to understand the Hess law. What is Hess law? Hess law, it is a reaction that takes place in the several steps. Then its standard reaction enthalpy is the sum of the standard enthalpies of the reaction, intermediate reactions into which the overall reaction may be divided at the same temperature. So to understand this all the concept, you must know about that how to overall do the reactions. Got it, everyone? Hope all of you have understand. If you are having any doubt regarding this Hess law, then you can just drop it out into the comment box section so I can understand that you are having this type of doubts, right? Now second thing, as you have understand the concept about these all the things, that what is Hess law in general is the enthalpy of overall reaction. Just suppose here this diagram. Okay, in this diagram, can you tell me that overall reaction from A to B, this was the first reactant and this is product. Okay, in this final product, first initial and this is final. Okay, this is the reactant and this is product. So now you just see this reaction. In general, if I talk about the enthalpy overall reaction, here you can see in the first step, that is delta HR1, delta HR2, delta H3. And here delta HR means rate of enthalpy of reaction A to B. You can see in this general overall reaction enthalpy. We have done what will be the overall reaction enthalpy here. So overall enthalpy reaction delta HR is equal to here. So delta HR is already given. So it is delta HR1 plus 2 plus 3 means whatever the several steps are there, it is equal to that now. As I have told you, it can be directly in one step also and it can be in the several steps also. So whatever the several step enthalpies are there, at the same temperature you have to just do the sum of all the enthalpies, that is equal to one step enthalpy. Got it? So this was our Hess law. Now second thing is enthalpies for the different types of reaction. Now we are going to discuss about the different types of reaction. So is there any doubt in this Hess law? If you are having doubt, then please drop it down into the comment box section. And if you want to take a screenshot, then you can take a screenshot of this board. So it will be easy. And already these all the things are represented in your NCERT textbook also. It's only the question is that you should learn something new. That is nothing else. Okay. So let's move ahead. Next one is standard enthalpy of combustion, means enthalpies for different types of reactions. So our new topic name is enthalpies for different types of reactions. Okay. So first of all, I would like to ask you, in the previous video, in lecture number 6, I had talked about the standard enthalpy. Have you remembered the word standard enthalpy? Yes or no? Reactant and product 1. If you have remembered, then it's very easy. Just pause a second video and just rewind that what I have said you in the previous video. So this new topic is enthalpies for different types of reaction. So now just tell me one thing, that if you burn something, this combustion process, if I talk about especially about the combustion process, if I want to burn something, directly understand combustion process. Combustion process is exothermic or endothermic? Can you tell me? Combustion process. I hope all of you know, in the combustion process what happens, heat get evolved out. When you burn something, you get heat. You feel heat or not? You feel warm or not? Definitely you feel. So it is an exothermic reaction. If it is an exothermic reaction, then you know very well what will be the enthalpy of combustion in the exothermic reaction. If I talk about just suppose in a simple amount that there is a reactant, and as the reactant burn, it gives you product. Okay. Especially about this is combustion reaction. Okay, this is a combustion reaction. So in this combustion reaction, can you tell me that what will the you can say about that specific enthalpies or special enthalpies about this reaction in the exothermic, or you can say the burning any substance. you know very well in your house that your mama, when she cook rice and she convert rice into the boiled rice with the help of what, you know, with the help of cylinder, that LPG gas, as she put on the pressure cooker on the LPG gas. So LPG gas just produces a heat and that rice convert into the boiled rice. But you know, have you ever thought which chemical is present inside that LPG? That is normal butane. Which chemical is present inside that cylinder, LPG cylinder? That is normal butane. Remember that normal butane. During this combustion, 1 mole of butane produces 2658 kilojoule per mole. I am talking about. Now you can say me, sir, how you will understand. Means at 1 second, you 1 mole for 1 mole, how much it is producing. Just suppose that normal butane is C4H10. This is normal butane, nothing else. Okay. Now you are burning this normal butane. What you are doing? Burning this normal butane. You are doing the reaction with O2. 13 by 2. I have done here 13 by 2. Why? I will tell you that. Because here whatever the amount we are getting, what we will get as we burn this normal butane, then what you will get? Carbon dioxide plus H2. That is 4 carbon dioxide plus 5 H2. Right? See why I have done? Because 13 molecule of oxygen I need. 13 mole of oxygen. 4 2 is 8 plus 5 13. So that's why I have done 13 by 2 O2. Now you will understand why I have done. Now here if I talk about what will be the enthalpy of this combustion, means delta HC, enthalpy of combustion. What will be the value? As right now only I have said you, that is 2658. 2658 kilojoule. Now you can ask me, sir, as you have said about the mole also per mole. In 1 mole this much amount of energy is released. To burn 1 mole of this normal butane, 2658 kilojoule enthalpy combustion is required. In general, as I have told you, this is a combustion reaction. Which reaction? Combustion reaction. Remember this. In this combustion reaction, reactant to product normal butane. This is your LPG gas. Okay? Liquefied petroleum gas. So this liquefied petroleum gas, as I have burned, sometimes it happens now that fire has caught in the LPG cylinder only. So to burn this much heat, enthalpy has been exhaust, means it has came out. Exothermic reaction, that's why it's written minus 2658 kilojoule. Now question is, if we burn glucose in our body, glucose C6H12O6, this is glucose, right? If we burn this glucose, then how much amount of heat is produced inside our body? Have you ever thought? Just put in mind. If we are doing, I am telling you, as this glucose is burned, 6O, what will happen, you know? 6CO2 plus 6H2O. Is there anything else produced? Should you tell me? Nothing. There's nothing produced. So you can see here, as what I have done, this is also exothermic reaction. Glucose has burned. So here delta Hc value, can you tell me what will be the combustion heat enthalpy's value? That is 2802 kilojoule per mole. Now just suppose about this reaction. What will happen in this reaction? Our body also generate energy from food by same overall process by the combustion, although the final products are produced after a series of complex biochemical reaction involving. See, just remember, whatever the things are being combustion, जो कुछ भी जलता है, तो जलने के साथ वो heat enthalpy is produced करता है, right? So as it burns, as right now I have just shown you, have you ever thought when anything burning is exothermic, means evaluation of heat, इवोल्यूशन ऑफ हीट इज एक्सोथर्मिक रिएक्शन. कोई भी चीज को आप जलाओगे तो उससे हीट जो प्रोड्यूस हो रहा है, बाहर निकल रहा है, दैट मीन्स इट इज एन एक्सोथर्मिक रिएक्शन. एंड व्हेन हीट इज गोइंग इनसाइड, दैट इज एंडोथर्मिक रिएक्शन. नाउ क्वेश्चन इज how we will understand this burning process. So that's why I have taken here normal butane. Normal butane को हमने जलाया. What we have done? We have burned this normal butane. So because I have told you it is an exothermic reaction, so it produces carbon dioxide and water. And what was the enthalpy in this combustion reaction? So enthalpy of combustion was 2658 kilojoule per mole. And similarly, if I talk about the glucose, इसी तरह whatever you are eating, कुछ भी खाना हो, यहाँ पे तो ग्लूकोज का इसलिए स्पेसिफाई है. कभी तुमने सोचा है कि हमारे बॉडी में हम जितना कुछ भी खाते हैं वो चलता कैसे है, किस तरह से रिएक्शंस होते हैं और क्या क्या बनता है, कितना अमाउंट ऑफ एनर्जी हमें मिलता है. यू नो समटाइम्स इफ यू हैव रीड 6 और 7 स्टैंडर्ड, तो उसमें एक क्वेश्चन आया था कभी, मुझे याद है जहाँ तक, एक बार मुझे एक बच्चा, सर वाई ग्लूकोज इज कॉल्ड इंस्टेंट एनर्जी. ग्लूकोज तुरंत एनर्जी क्यों देता है, इमीडिएट एनर्जी, इंस्टेंट एनर्जी. वाई ग्लूकोज इज कॉल्ड एन इंस्टेंट एनर्जी. So this was the right answer of that question, that glucose produces 2802 kilojoule per mole. एक मोल ग्लूकोज इतना एनर्जी आपको देता है. Then definitely you will suddenly you will wake up, you will get a lot of energy, right? So that was the main thing which you understand about this reaction. Let's move towards one numerical of this. The combustion of 1 mole of benzene take place at 298 Kelvin and 1 atmosphere. After combustion, carbon dioxide and water are produced and 3267 kilojoule of heat is liberated. Calculate the standard enthalpy of formation of benzene, standard enthalpy of formation of carbon dioxide and water are minus 393.5 kilojoule per mole and minus 285.83 kilojoule per mole. सबसे पहले आपको ये समझना होगा कि रिएक्शन में बेंजीन बन रहा है, राइट. बेंजीन को वापस जलाया गया तो कार्बन डाइऑक्साइड और वाटर मिला, जिसमें रेस्पेक्टिवली जो भी अमाउंट ऑफ इंथैल्पीज दिया गया है. आपको निकालना क्या है? यू हैव टू फाइंड स्टैंडर्ड इंथैल्पी ऑफ फॉर्मेशन. स्टैंडर्ड इंथैल्पी ऑफ फॉर्मेशन याद करो, मैंने बताया था 1 मोल स्टैंडर्ड इंथैल्पी ऑफ फॉर्मेशन, यू मे हैव रिमेंबर्ड. सो लेट्स फाइंड आउट दैट न्यूमेरिकल. See, we are going to first of all find the formation of reaction of benzene, how this benzene is formed. You know very well, when carbon, that is graphite, carbon is reacted with hydrogen, it gives you C6H6. Here delta HF is equal to, this is our question, right? And the enthalpy of combustion of 1 mole of benzene is given here. Enthalpy of combustion of 1 mole of benzene is already given in the question, that C6H6 means enthalpy of combustion of benzene is when burned with oxygen. See why I have written here 15/2, that also I will tell you. I require 15 oxygen, that's why. Yes, you can see, is this reaction balanced? And here in the question it is given that the combustion is benzene standard enthalpy combustion formation, H2O is minus 393 and minus 285. So first of all, in this question it's given here that 3267 kilojoule of heat is released. So the enthalpy of combustion is 3000, how much? 3267 kilojoule per mole. This enthalpy of combustion is given, and enthalpy of formation is also given. means for carbon dioxide and water, enthalpy of formation is given C plus O2. Carbon dioxide, C plus O2 is equal to CO2, and enthalpy of formation is given here. That is how much? Minus 393.5 kilojoule. Minus 393.5 kilojoule per joule. And water, H2 plus half O2, that is called H2O. And here also the standard enthalpy of formation is given. How much? Minus 285.83. Minus 285.83 kilojoule. So now you can see in the question what the things are given and what the things we have to take out from this image, right? Now you can see here our first reaction, 6C plus 3H2. 6C plus 3H2 is C6H6, and here you can see multiply this equation by 6. Multiply this equation by 6 and multiply this equation by 3. This is your, just suppose this is your first equation and this is your second equation. If you will multiply this equation by 6 and you will multiply this equation by 3, so what will happen? Now equation 1 into 3 and equation, 1 into 6, not 3. 1 into 6 and 2 into 3. So what you will get, can you tell me? Just suppose what you will get. The same thing, whatever you want to calculate, that is C6C plus 3H2, that is equal to C6H6, and whatever the enthalpy of formation was given of equation first and second, as we have multiplied by first equation by 6 times and second equation by 3 times. So the final answer is minus 2361. How much? Minus 2361. So what I have done, I have just telling you. This equation is multiplied by 6 and this equation is multiplied by 3. अब देखो तुम खुद सोचो दिमाग में, 6 से मल्टीप्लाई करोगे, ये भी 6 हो जाएगा, ये भी 6 हो जाएगा, ये भी 6 हो जाएगा, यहाँ पे भी 6 हो जाएगा. And here I am multiplied by 3. So you know very well, 6 3 is 18 and 2 3 is 6, something ऐसा ऐसा ही जो भी वैल्यू आएगा. And you know very well that enthalpy of formation, standard enthalpy of formation, 1 mole formation के लिए जो हम लोगों ने फॉर्मूला था, तो फॉर्मूला पे बिठाएंगे डेल्टा HF माइनस जो हमारा वैल्यू है, दैट इज इक्वल टू माइनस 2361 किलोजूल पर मोल. ये हमारा आंसर है. नाउ क्वेश्चन इज, हियर वी हैव जस्ट टॉक्ड अबाउट द फर्स्ट वन, benzene one, and in the second question it is given that whatever the water molecules are there, 3 molecules of water. Now for 3 molecules of water means 3H2, this one, this was the first reaction, we have multiplied by 6 and second one by 3. तो अगर हम 3 से इसको मल्टीप्लाई करेंगे तो क्या होगा, जरा बताओ, फटाफट बताओ. अच्छा थोड़ा एक काम करो, बताओ तुम लोग, एक दिमाग में पूछो, तुम लोगों को गाड़ी लगता है, मैं फिर से बताएगा, टेंशन नहीं. चलो 1 को हमने 6 से मल्टीप्लाई किया तो क्या हो जाएगा, 6C plus 6O2 that is equal to 6CO2 होगा. इक्वेशन नंबर 1 होगा या नहीं होगा, बताओ पहले. होगा. इज इक्वल टू डेल्टा H जो है हमारा, डेल्टा HF माइनस इज इक्वल टू 6 इंटू minus 393.5 kilojule per mole. Okay, तो मल्टीप्लाई करो, 5 6 जा 30, 3 6 3 जा 18 and 3 21, 2 6 9 जा 54, 54 और 2 56, 5 6 3 जा 18 and 5 20. तो minus 2361 हो गए पहले वाले का, बराबर. अब दूसरे वाले का देखो, दूसरा वाले का 3 से मल्टीप्लाई करना, 3H2 plus 3/2O2 is equal to 3H2O. यहाँ पे डेल्टा HF माइनस कितना हो जाएगा, कितना 3 से मल्टीप्लाई कर, 3 इंटू -285.83 किलो जूल पर मोल, बराबर। 3 से मल्टीप्लाई करेंगे, 3 3 जा 9, 8 3 जा 24, 5 3 जा 15 इंटू 17 1, 8 3 जा 24 इंटू 1 25 2, 3 2 जा 6 इंटू -857.49 किलो जूल पर मोल, बराबर। देखिए बराबर है, राइट। अब जो है समेशन करना है, पूरे रिएक्शन को सम अप करना है, मतलब सारे रिएक्शंस को, अब जो भी तुम्हें वैल्यूज आया है ये सारे रिएक्शन को सम अप करना है, मतलब इसको 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 और इसको ऐड करना है, मतलब कार्बन ऑक्सीजन हाइड्रोजन ऑक्सीजन सबको ऐड कर देंगे, तो क्या हो जाएगा, देखो कुछ नहीं करना है, हमें जो रिएक्शन मिला है बस उसको ऐड कर देना है। क्या करना है, ऐड कर देना है। चलो देखिए, ये मान लो रिएक्शन नंबर 3 और ये रिएक्शन नंबर 4। नाउ 3 + 4 बराबर 3 और 4 को ऐड करेंगे, क्या हो जाएगा 6C + 6O2 + 3H2 + 3/2O2 = 6CO2 + 3H2O, बराबर। એટલે 6C प्लस, अब यहाँ पर O2 को करो, 6 2 = 12 + 3 15/2O2 + 3H2 = 6CO2 + 3H2, बराबर। नाउ यू हैव टू जस्ट डेल्टा HF का वैल्यू निकालना है, डेल्टा HF हो जाएगा इतना प्लस इतना, दोनों को ऐड कर दो कितना, तो ये हमारा 0.49 तो रह जाएगा किलो जूल पर मोल, और इधर आप ऐड करो 7 + 1 8, 5 + 6 11, 1 8 + 3 11 + 1 12, એટલે -3218 -3218.49 -321849, बराबर। ये रिएक्शन से तुमको मिल गया -3218.49 किलो जूल पर मोल। अब तुमको क्या करना है, इस रिएक्शन को रिवर्स कर देना है, बराबर। क्या करना है, रिएक्शन को रिवर्स कर देना है। कौन सा रिएक्शन, रिएक्शन नंबर 5 और रिएक्शन नंबर 6। कहाँ से मिला तेरे को 5 और 6, अब देख लो, अभी जो वैल्यूज आपको मिले हैं ये 3218.49, ये रिएक्शन हमारा 5 हो गया, और रिएक्शन 6 जो है हमारा स्टार्टिंग वाला है, रिवर्स कर देंगे हम लोग, बराबर। क्या करेंगे, रिवर्स कर देंगे। रिवर्स करेंगे तो रिएक्शन का एंथैल्पी कुछ अलग अलग होगा। जो स्टार्टिंग में दिया हुआ था हमारा 3267, याद करो, ये रिएक्शन देख लो, दिख रहा है ये वाला रिएक्शन, बराबर, ओके। एंड व्हाट एवर द रिएक्शन वी हैव गॉट राइट नाउ, ये वाला रिएक्शन, इसको मान लो रिएक्शन 5, बराबर। यहाँ पर तुमको 3267 किलो जूल पर मोल है, और यहाँ पर 3218.49 किलो जूल पर मोल है, बराबर। तो अब अगर तुम रिएक्शन को रिवर्स करोगे तो क्या होगा, तुम्हारा वैल्यूज, अब जो प्लस है उसमें से माइनस कर दो, 3267 में से 3218 माइनस करोगे, जो भी वैल्यूज आएगा वो तुम्हारा निकल जाएगा, बराबर, कितना बराबर, देख लो। बाय रिवर्सिंग द इक्वेशन 2, अब मुझे दिख रहा आकार वैल्यू मनी, बराबर। હવે પાછળ આ રિએક્શન ને તું રિવર્સ કરી નાખ, રિએક્શન ને રિવર્સ કરશે તો શું થઈ જશે, અહીંયા 6CO2 + 3H2O = C6H6 + 15/2O2, બરાબર થઈ ગયું। અને આનો ડેલ્ટા HC નો વેલ્યુ કેટલા થઈ જશે, કમ્બશન, that is equal to 3267 કિલોજૂલ પર, બરાબર। આ થઈ ગયું તારો ઇક્વેશન નંબર 6, અને આ થઈ ગયું તારો ઇક્વેશન નંબર 5। 3267 અને 3218, હવે બસ એડ કરવાનું છે તારું, બધું મળી ગયું તારું, each and everything will be equal, just see In equation number 6, 6 CO2 3 H2O, 6 CO2 3 H2O. अब नो आंसर, then the value will be 6C plus 15 by 2 O2 plus 3 H2O. 15 by O2 15 by O2 cancel, C6H6 છે. તો આ રિએક્શન તમારું મળી ગયું અને આમાં બસ ખાલી શું કરવાનું, એડ કરી દેવાનું છે. આપણે એડ કરીએ તો કેટલા થઈ જશે? જો what will the value that delta HF is equal to, ये जो है हमारा 3267 minus 3218. अब देखो 32 67 में से अब 67 minus 18, अब ये 17 में से 8 गया, ये हो गया 9 और 0.49 भी है, 3218.49 बराबर. तो 10 minus 9 1, 9 minus 4 5, फिर आठ गई तो 6, 6 minus 8, 16 minus 8 8 बराबर. आप गई 5, 5 minus 1 4, मतलब 48.51 किलोजूल पर मोल इज द राइट आंसर. इसमें करना क्या था, पहले इस चीज को समझ लीजिए. क्वेश्चन आपका पूरा दिया हुआ था, द कंबशन ऑफ 1 मोल ऑफ बेंजीन आपको निकालना है. 1 मोल ऑफ बेंजीन निकालना. क्वेश्चन में दिया हुआ था कि C6H12O6 plus 15O2 is 6CO2 plus 3H2O. इसका जो है आपका डेल्टा हीट कंबशन दिया हुआ है -3267 किलोजूल पर मोल. ओके. सेकंड थिंग हियर, दैट इज 1 मोल ऑफ फॉर्मेशन हीट एंथैल्पी का फॉर्मेशन है, दैट इज ऑफ कार्बन डाइऑक्साइड एंड वाटर इज गिवन. व्हाट वी हैव डन, we have to just arrange the equation to get the value of this benzene formation. So what I have done, I have multiplied this equation by 6 and this equation by 3. Why I have multiplied? To get the reaction of this benzene one. So as I have multiplied this first equation by 6, I have got the formation heat enthalpy minus 2361. As I have multiplied the equation second with 3, I have got minus 857.49 kilojoule per mole. Now what I have done, I have added both the reaction 3 plus 4. So as 3 plus 4 I have done, I have got delta heat enthalpy minus 3218.49 kilojoule per mole. Now what I have done, I have reversed this reaction. Reverse this reaction means 6CO2 plus 3H2O is equal to C6H6 plus 15 by 2O2, and here I have got the positive value, that is 3267. Now you can see both the reactions were same. Now equation number 6 and equation number 5 I have added and I have got the delta HF value, that is 48.51 kilojoule per mole. There's nothing else. बहुत बच्चे लोग क्या होते हैं कि घबरा जाते हैं कि ऐसा ऐसा क्या किया सर, पता ही नहीं चला. कुछ नहीं, दिमाग को ठंडा करो, बस समझो कि हमें करना क्या है. पहले तो रिएक्शन लिख देना बेंजीन का. बेंजीन के रिएक्शन में क्या निकालना, ये हमारा क्वेश्चन है. ये हमारे क्वेश्चन में दिया हुआ है, ये दिया हुआ है, ये दिया हुआ है. इसको 6 से मल्टीप्लाई किया, इसको 3 से मल्टीप्लाई किया, फिर दोनों को जोड़ दिया, फिर इस रिएक्शन को रिवर्स कर दिया, फिर रिवर्स वाला रिएक्शन और जो हमारा मेन रिएक्शन निकला था 3 plus 4, उस दोनों का ऐड करके जो वैल्यू हुआ उस दोनों को जोड़ दिया. फाइनल आंसर हमारा इतना आ गया 48.51 किलो. तो इसमें रिएक्शंस है, मतलब आप कह सकते हैं न्यूमेरिकल वैल्यू है. ये थोड़ा आपको मतलब एलिमिनेशन मेथड जो 10th में आप लोग करते थे, सॉल्व याद करो 10th स्टैंडर्ड में जो फर्स्ट चैप्टर था ना, 2 लीनियर इक्वेशन वाला, उसमें जो एलिमिनेशन मेथड यूज करता था, इसको 6 से इतना से मल्टीप्लाई, x वाले को y से, y वाले को x से, फिर एक वैल्यू हम लोग एलिमिनेट कर देते थे. बिल्कुल वैसा ही किया मैंने और यहाँ पर फाइनल वैल्यू मेरा निकल गया 48.51 किलोजूल पर मोल. सो दिस वाज द मेथड बाय व्हिच वी कैन सॉल्व द न्यूमेरिकल. होप ऑल ऑफ यू अंडरस्टैंड. आप लोग अगर स्क्रीनशॉट लेना चाहते हैं तो ले सकते हैं, अदरवाइज ये आपका न्यूमेरिकल का प्रॉब्लम सॉल्व वाला है. होप आप लोग समझ गए होंगे. अगर फिर भी कोई दिक्कत होगा आप लोगों को समझने में तो आप लोग कमेंट बॉक्स में डाल सकते हो कि सर मेरे को ये नहीं समझ में आया, वो नहीं समझ में आया. जो भी आपका प्रॉब्लम है आप डाल सकते हो, बराबर. चलो अब जो है आपको नया टॉपिक है इंथैल्पी ऑफ एटोमाइजेशन. ये हम लोग नेक्स्ट वीडियो में इसलिए पढ़ेंगे क्योंकि आप लोग पहले किसी भी चीज को समझने की कोशिश करो. जब तक समझोगे नहीं तब तक बढ़ोगे नहीं. इंथैल्पी फॉर डिफरेंट टाइप्स में पहला था हमारा स्टैंडर्ड इंथैल्पी ऑफ कंबशन रिएक्शन. कंबशन मतलब जलने वाला, एक्सोथर्मिक रिएक्शन में हीट का जो वैल्यू आएगा वो माइनस में आएगा। इस तरह का बहुत सारा क्वेश्चन हो सकता है, आप लोगों को दिमाग लगाना है और इस तरह के रिएक्शन। तो आप लोगों को एक बार और इस रिएक्शन को ध्यान से देखना है, ध्यान से समझना है। अगर कोई दिक्कत होगी तो आप लोग मुझे डेफिनेटली डाउट जो कमेंट सेक्शन है हमारा यूट्यूब में, उसमें आप कमेंट कर दो, सर मेरे को ये नहीं समझ में आया, डेल्टा हीट इंथैल्पी ऑफ फॉर्मेशन समझ में नहीं आया, डेल्टा हीट इंथैल्पी कंबशन समझ में आया, जो भी नहीं आया मेरे को आप डेफिनेटली। आई होप आप लोगों को वीडियो समझ में आया होगा। अगर समझ में आया होगा तो लाइक और सब्सक्राइब करें, अपने दोस्तों के साथ शेयर करें ताकि वो बेनिफिटेड हो सके। दैट्स ऑल फॉर टुडे। थैंक यू वेरी मच।